Hello and welcome to Learn Yourself. Today we are going to learn about a periodic table from the syllabus of ICSE Standard 9. So this is giving a general idea about a periodic table which you are going to learn in detail in Standard 10. So what is a periodic table? How we have arranged all the elements, why we have arranged, and some trends we have followed. So in Standard 9 we are going to learn about all the basic details of periodic table, elements, how they have arranged and why they have arranged. This is very basic information and it is also very important to learn Standard 10 chapter. So let us start with the chemist who have tried to arrange a certain elements in certain specific trends or certain specific arrangement. So there are total 4 scientists in your syllabus who have tried to arrange elements in certain pattern. All of them have followed a different rules and different arrangement. In all this arrangement, some defects were there, some limitations were there. Why and how we are going to learn it. First was the Dobereinear. Dobereinear has arranged all the elements in the form of triads. So this is known as Dobereinear's triad. He has given a certain group of the elements in the form of 3 elements and he has arranged in that. Second, Newland. He said that every 8th element is the repetition of the first. For example, sodium, its atomic number is 11. So after 8th element, you are getting a 19 potassium. That is also a alkali metal. So Newland was the first chemist who has found out that every 8th element is the repetition of the first. So we can see some similarities in the property of those elements. So Newland was the first chemist who said that every 8th element is the repetition of the first element. After that, Mandeleef. Mandeleef is known as a father of periodic table. Elements with similar properties appear at regular interval. He also said the same thing in a different way. That one element when you are placing after some elements, again which element has come, it's showing the same property. So it comes after regular interval. So if it is an 8th element, then again after 7th element, the 8th element will be the same one. Till here, all of them have arranged according to atomic mass and not according to the atomic number. Dobereinear, Newland and Mandeleef. All these 3 chemists have arranged a periodic table according to atomic mass. And Mosely was the first chemist who has arranged a periodic table by following atomic number. He said that properties of elements are periodic function. Periodic function means which is repetitive and which is repeating after certain interval of time. As we have learned as a periodic change. Seasons are the periodic change. Same way. Periodic functions of the atomic number. And Mosely was the first one who has arranged all the elements as per their atomic number. So this is the basic information and rules what they have given. Now we are going to learn about all of them in detail by giving one example each. Dobereinear's law of triads. It is known as law of triads because Dobereinear has given a group of 3 elements and he has observed certain properties among them. So as per the law, it is said that chemically analogous element arranged in increasing order of their atomic weight. So he has selected some of the elements which he found that they are chemically analogous. That means they have some similar chemical property. And he found out that is a group of 3 elements. So that's why he has arranged them in a group of 3 elements, in which atomic weight of the middle, where he has arranged, for example, this is lithium, sodium and potassium. He has given this triads, in which he said that atomic weight, he has arranged all this in increasing order of the atomic weight, and he said that when you are arranging these elements in increasing order of atomic weight, the average of the first and third element you will get as second element. So he said in which atomic weight of the middle will be the average of the other two. So this atomic weight will be an average of these two elements. So he has given some example like this, and he has arranged all the elements in a group of 3. That's why it is known as law of triads. But at some point of time, this law was not hold true for all the elements, and some of the triads which he has given was not chemically same. So these two were the limitation that we have not accepted this Dobereinier's triad. So what are the two limitations? First, it was not hold true for all the elements. Some of the elements were not fitting into this group of 3 elements. In that group, all the elements were not chemically same. He found out that they are chemically analogous, but after certain discoveries, chemists have found out that these 3 elements are not chemically analogous. So that's why Dobereinier's law of triads was failed to prove its importance. Newland's law of octave. Newland chemist has given octaves. He has derived this from a certain musical notes, which gives a group of 8 elements. And he also said that elements, when we are arranged them in the increasing order of their atomic weight, he also arranged all the elements according to their atomic weight. It shows similarity in chemical and physical properties between first and 8th element. He said that when we are grouping them in the group of 8 elements, so the next element which we are going to keep under the first element, it shows the similar properties in terms of physical and chemical with the first element. Again, when we are arranging elements in the increasing order of their atomic weight and we are forming a group of 8 elements, the 9th element will be the similar, 9th elements having the similarities with the first element in terms of physical and chemical properties. So he was the first scientist who said that properties are repetitive. So here this is the example for Newland's law of octave, and the important thing that he has derived this from the musical note. Somehow this law also did not work well. So which are the limitations? First, he has not left the space for undiscovered element. This scientist has given this law when some of the elements were yet to discovered. So he has not left any space for some undiscovered element. So afterwards, when those elements has been discovered, it was a problem that where those elements should be fitted. Then second, this law itself was failed to prove its importance for the heavy metals and beyond a potassium. That means for the light metals and light elements, till potassium, till atomic number 19, this law was hold true. But beyond that, for the heavy elements, this law was not correct. So these were the limitations of Newland's law of octave. Mandeleef's periodic table. Mandeleef was the first chemist who has given a periodic table name to the arrangement of elements, and his contribution has been largely appreciated, so he was called a father of periodic table. So let us first see the law of Mandeleef's periodic table. He said that the physical and chemical properties of elements are periodic function of their atomic weight. He was the first one who said that these are the periodic function. Periodic function means they are repetitive after certain repetition of certain number of elements. So they are periodic function of their atomic weight because he has arranged all the elements according to their increasing number of atomic weight. And how his contribution was so important, let us see some points. He has arranged elements in periods and groups. He has arranged them in the form of table, and he has said that the horizontal rows are called periods and the vertical columns are called groups. Second, same group, same valency. So he said, and he has arranged the elements like the elements which comes in the same group are having the same valency, that means they are having the same valence electrons. He also left some gaps in between for the undiscovered element. In that time, some elements were not yet discovered. So by arranging elements, he felt that this gap is more. Actually, one element should come in between. So he left gaps for that. So it was helpful for other scientists to find out those missing elements due to his arrangement. Last point. Incorrect atomic weight of elements have been corrected. By arranging them in periods and groups, by seeing ascending and descending order of elements, they could judge that this element's atomic weight has been wrongly calculated. So those mistakes also rectified due to the arrangement of this periodic table. There were some defects in Mandeleef's periodic table. So first one, cobalt was placed before nickel, whereas cobalt's atomic weight was higher than nickel, then also it was placed before nickel. Second, position of rare earth elements and actinides. This position of rare earth and actinide is justified only if we are arranging them in according to their atomic number. It cannot be justified when we are arranging them in atomic weight. So this position of rare earth and actinide was not justified in the arrangement of Mandeleef's periodic table. Third one, the position of isotopes. When we are talking about isotopes, for example, hydrogen. Hydrogen has 3 isotopes, protium, deuterium and tritium. Then hydrogen will require 3 different places, even though it is a same element. So this thing cannot be justified when we are talking about Mandeleef's periodic table. So position of isotopes were not justified in the Mandeleef's periodic table. Mosely's periodic table. He was the first person who has arranged all the elements in their increasing order of atomic number. He has given a law which says that the physical and chemical properties of elements are periodic function. That means they are repetitive at certain interval of their atomic number. Physical and chemical properties of elements are periodic function of their atomic numbers. When Mandeleef has said that physical and chemical properties of elements are periodic function of their atomic weight. This is the difference between Mosely's law and Mandeleef's law. Mandeleef says that it is according to the atomic weight, whereas Mosely said that it is according to its atomic number. Alkali metals. So through this we will see how those particular groups are having similar properties and similar trends. So in this we are going to see alkali metals, alkaline earth metals, halogens, transition elements and noble gases. So this 5 types of groups we are going to see individually. And we are going to see that how they are making a compounds and what all chemical and physical properties they are shared among their group. So first one is alkali metals. Which are the alkali metals? The first group of the periodic table, they are alkali metals. Sodium, potassium and all are the part of that group. So group 1, and they are light elements. I have mentioned some of the important points for alkali metals. These points will help you to remember the important features of alkali metals, as well as if you want to write a short note, you can form a sentence and you can mention all these important points. First, they are from the group 1 and they are light elements. They are strong reducing agent, they are electron donor, and only one electron is there in their valence shell. Let us take an example of sodium metal. Its electronic configuration is 2, 8 and 1. Its valence shell is consisting of 1 electron, and so on for all the alkali metals they are having 1 electron in their valence shell. So it is very easy to donate that 1 electron. That's why they are good reducing agent as well as they are electron donor. This 1 electron is very easy to take out. So they easily donate this 1 electron. They are highly reactive. Because of this 1 electron, they are easily lost this electron and gain a positive charge ions. And that's why they are highly reactive. Easily that 1 electron is been removed. They are soft metal. Sodium and potassium we can cut with the knife. They are soft metals. They are good conductors of heat and electricity. Because they are metal, they possess all the properties of metals. They form electrovalent compound. What are the electrovalent compound? Electrovalent compound are the compounds which are formed by transfer of the electron. They can easily remove this 1 electron. So this electron has been transferred to non-metal element. So they form compound through electrovalency. So these are some important points for alkali metals. Let us talk about alkaline earth metal. This is the next group from alkali metals. This is a group number 2. So alkaline earth metal is from group 2. They are also light metals. 2 electrons are there in their valence shell. Now one very important feature of periodic table is that whenever you are checking that how many valence electron are there in particular element, so you can easily find out from that group number. If it is from the group 1, they are consisting 1 valence electron. If they are from the group 2, they are having 2 electrons in their valence shell, and so on. So group 2 is having 2 valence electrons. For example, magnesium. So magnesium's atomic number is 12 and its electronic configuration is 282. So these 2 are the valence electron. So they are having the same properties like alkali metals, but compared to alkali metals they are less reactive, because in alkali metals they are having 1 valence electron, whereas here they are having 2 valence electron. So this makes them less reactive compared to alkali metals. We all know that halogens are chlorine, bromine, iodine, fluorine and so on. They are placed in a group number 17 and consolidated group 7A. Since they are from the group 7, they are having 7 electrons in their valence shell. They are non-metals, 7 electrons in their valence shell. That's why they are also called univalent. For example, chlorine. Its atomic number is 17. What can be its electronic configuration? 2, 8 and 7. If chlorine wants to be stable, it has to accept 1 electron and can make 2, 8, 8. So, it requires 1 electron to be stabilized. That's why it is known as univalent. Also, alkali metals. For example, sodium. Its electronic number is 11 and electronic configuration is 281. So, if sodium wants to be stabilized, it has to donate 1 electron and become stable like neon. Because of that, alkali metal is also called univalent. By donating or accepting 1 electron, they are become stable. So, they are known as univalent. If by accepting or donating 2 electrons they will become stable, they are known as divalent, and so as alkaline earth metal. For example, magnesium. So, it will donate 2 electrons and become stable. So, they are known as divalent. Whereas here, halogens, they will accept 1 electron and they will become stable. That's why they are known as univalent. And they are strong oxidizing agent, opposite to alkali metals. Alkali metals are strong reducing agent, whereas here they are strong oxidizing agent. If you have any doubt regarding oxidizing and reducing agent, please check my video based on oxidizing reducing agent explanation. They are highly reactive and they are bad conductor of heat and electricity. The name suggests that Hal means salt and Gen means producer. They are also known as salt producer. For example, sodium and chlorine, they are producing salt. That's why they are called halogen, halogen, salt producer. Also, they are making covalent compound with non-metal. For example, HCl, it is a covalent compound. With non-metal, halogens are making covalent compound, and with metal, halogens are making electrovalent compound. So this is all about halogen, and they are from the group 7 or 17. So what are the noble gases? Noble gases are placed at extremely right of modern periodic table. So first are alkali metals, then alkaline earth metals, in between transition elements, then halogens, they are non-metals, and then last noble gases are there. So they are placed in the 18th group. They are also called as zero group element because their valency is 0. Their outermost shell is completely filled. These elements are starting from helium and goes up till radon. So helium is the first element. Its atomic number is 2. So helium is the only element in which outermost shell is filled with 2 electrons and it's completely filled. The K shell is completely filled with 2 electrons. Rest all elements are having 8 electrons in their valence shell. So they are having 8 valence electrons. For example, neon. Neon's atomic number is 10. If we are writing electronic configuration, then it will be 2, 8. So they all are having 8 electrons in their valence shell. Then they are stable because they do not want any electron in their valence shell. Their valence shell is completely filled, so that's why they are stable. And they are monoatomic. Since they don't want any other element to help them to be stable, so that's why they will not form any compound. For example, sodium. Sodium is alkali metal. It has 11 electrons. And if you will see, 281 is its electronic configuration. It requires either 7 electrons here or it needs to donate 1 electron. Because of this reason, it is not stable and it will go for compound formation. But here in neon, it is already stable. So, it do not need any other atom to become stable. That's why they are monoatomic. They exist in nature in monoatomic. If hydrogen wants to exist alone, it has to form H2 molecule. Alone hydrogen cannot be stable because it has only 1 electron. But this is not the case with the noble gases. So all the noble gases atoms are monoatomic. They are stable. They have zero valency because their outermost shell is completely filled.